All right, so this video is about graphing secant and cosecant, and this will kind of be the explanation video of how it works. But you would need the foundation of how to graph sine and cosine in order to know what I'm talking about here. So if you need to know how to graph sine and cosine, go ahead and take a look at one of my videos that talks about sine and cosine. But cosecant, so CSC. The reason why I say you need to know what sine and cosine are is because I like to show that obviously that the reciprocal of cosecant is sine, and I know that because it's going to help me identify some key parts to cosecant, okay? So I know that the reciprocal of cosecant is sine, okay? So I'm going to graph sine of x in red on my paper here, and notice how I made the amplitude 1, because it is 1, so that means I'm going to start at 0, 0, go up to 1, down to negative 1, back up to 0, all right? And this is one cycle, meaning it goes from 0 to 360, and then there's 180 right there. Okay, so that's one cycle. And it's important to identify where it does equal 0, because let's think about it. Sine of 0, another way to think about sine, if you were going around in a circle per se, and you were identifying the x and y values and the radius, or r, hypotenuse, it would be y over r, and wherever sine is 0, so like at 0 degrees, you would notice that there's no x value. But there is an r value, meaning the radius is something. The radius could be whatever it wants. The radius could be 7, 14, 29, it doesn't matter. But 0 over 29 is 0. 0 over 7 is 0. So that's why we just graph the point 0. But here's where it gets interesting. So let's say the radius was 7, okay? And so sine is 0 over 7, but cosecant is the reciprocal. So you take the reciprocal of 0 over 7, and you would have 7 over 0. So when you have a fraction, like 7 over 0, hopefully every alarm goes off in your brain because my teacher says I can divide it by 0. 0 can be in the denominator. And they're correct. This is what we call undefined. Okay? So this is undefined. Now, let's think about, so I drew the sine graph. So where sine is 0, think about it, cosecant is undefined. So where sine is 0, cosecant would be undefined. So it's important for me to know where the sine graph crosses 0, because when I graph this, I have to make sure I can't graph something there, right? Because undefined means I can't define it, I can't put a point on those undefined spots. And we put what are called asymptotes in those spots. So I graphed the sine graph to identify where the asymptotes should go, right there at 0, 180 degrees, and 360, because that is where sine is 0. And obviously I would know that for all the other, if I did 2 cycles or 3 cycles, every 180 degrees there would be an asymptote. Okay? So what I do from here is the reciprocal of sine, or the reciprocal cosecant sine, we graph sine. Now, normally people think, well, don't you just kind of graph it like this? Wouldn't the graph look like go down, come up, like this? Wouldn't that be the reciprocal of sine? And you'd say no, because look, my graph is touching the asymptote. So that's not the reciprocal or cosecant, because that orange graph I just did touches my asymptotes. So I can't use that. But look what it does here. Okay? So notice in the green, I have 2 kind of like parabolas. One on the top, on the left there, and on the right side, I have one on the bottom. So notice how it touches the original graph, because where sine is 1, cosecant is 1, because let's say it was 7 over 7. If I take the reciprocal of 7 over 7, it's still 7 over 7. So there's one spot where sine and cosecant are the same number, but notice how they go in opposite directions. And notice how my cosecant graph doesn't touch the asymptotes. It will just get really close. So even though these are in multiple parts, 2 of these kind of parabolas, if you will, or 2 of these U-shapes make one cosecant graph, or one cycle of the cosecant function. One part that's positive, one part that's negative. Just like sine, right? From 0 to 180, sine is positive, but from 180 to 360, sine is negative. Same thing here. Cosecant from 0 to 180 is positive. Cosecant from 180 to 360 is negative. So Anyway, that's what cosecant looks like. And again, I do that by graphing the sine function as a dotted line to give me my reference or kind of be my guide. And then I draw the cosecant graph. So I don't know how your teacher would do this. I prefer my students to draw a dotted sine graph and then to make solid lines for cosecant. You could use different colors. Some teachers make you erase the guide. For me, I think it shows that you have a firm understanding of sine and cosecant if you're able to do both. So that's what cosecant looks like. Now let's take a look at secant, which of course is the reciprocal of secant is cosine. Okay, so I'm going to graph the cosine graph, which is right there. Remember, cosine starts at 1, goes down to -1, then back up to 1. And it crosses 0 at 2 places, from 0 to 360. Okay, so 0 to 360, because we're graphing one cycle. Okay, it crosses at 90, so cosine of 90 degrees is 0, and cosine of 270 is 0. And remember, if cosine is 0 there, that means secant, its reciprocal, would be undefined, so we need asymptotes right here. So when I graph this, obviously that middle part, I have that downward facing u, or that would be n, if you will. And then I have these like 2 half pieces I have to put on the left and the right. So notice how, so you can graph the half piece like I'm on the left. I can graph a half piece like this, or you can graph the whole thing. Doesn't matter, because you can remember you can go to negative angles and it would still be there. And then same thing over here. I can draw the half, or I can do the whole thing. But one secant function looks like this from 0 to 360. Right, I have that whole u on the bottom, and then the 2 halves on the ends make a whole, so I have 2 u's, just like cosecant had 2 of them. Okay, so that is secant and cosecant. I always frame it with its reciprocal sine or cosine, and then using where sine and cosine are 0, give me my asymptotes, and that is where secant and cosecant stay in between. So that is secant and cosecant.